So we need to finish this problem from Wednesday, okay? So the end of class on Wednesday, we were talking about those inverse trig functions, okay? And I gave you a problem that you'll see something similar in the homework for the inverse trig, okay? That homework assignment is very short and it's due after the test. So, and I'm not going to, there may be one question on the test about inverse trig, okay? One. Does that make sense? I'm not going to overload you with a bunch of questions on the inverse trig because I know it's right before the test. And we're gonna see it again, believe it or not, okay? So yeah, this problem at the end of class on Wednesday, 3x plus 5 over x squared plus 1, you're gonna integrate, okay? Let's need one. So guys, yeah, gotcha. And I told you to split it, right? If we've got adding on top, we might be able to split that integral into two integrals that we can integrate, okay? So the suggestion at the end of class on Wednesday was, let's take 3x over x squared plus 1, and then 5 over x squared plus 1, separate them and integrate them individually, okay? And the suggestion was, let's let u be the denominator, x squared plus 1, on the 3x over x squared plus 1 integral, the first one. So your derivative is 2x. Did any of you get a chance to finish this one? What should dx be if we're going to solve for dx? Du over 2x. Good. And then we change that integral. We've got 3x on top over what? U times du over 2x. And the goal is to cancel all the x's so that you're left with only u's, right? We always do that with a u substitution. So I'm going to pull the constants out front. 3 halves du over u. Okay. Are we good so far? How do we integrate that? And if you don't like it like that, okay, move the du. How do we integrate that? What's the antiderivative of 1 over u? Natural log. So natural log of u. Okay. Are we good so far? Cool. We're going to keep the plus c until the very end because we don't want 2 plus c's. They're constants. We don't care about them. We just throw them on the end. Okay. I mean, we do care about them, but we don't have to have 2 separate constants when we're integrating. We just add them together and make them one constant. How about the second one? 5 over x squared plus 1. How do we integrate that? Remember what section you're in. Let's do one little change. Pull the 5 out. Right? Pull the constant out front. How do we integrate that? Tangent inverse. That is an inverse trig derivative. 1 over x squared plus 1 is the derivative of arctan or tangent inverse. Okay. So we're just going to change it to tangent inverse. And then we end up with plus 5 tangent inverse of x plus c. And we do one more change. What's left? Change the u back to x. Good. Our x was x squared plus 1. You don't have to put the absolute values in it, but if you do, it does not affect the problem, right? X squared plus 1 is already positive, so we don't have to have that absolute value there. Okay. Questions on that? So far? Seems okay? Okay. I'll leave it up there for a few seconds. You should have a study guide. It's 4 pages. I did find a mistake in the answer key that I will have you correct in just a moment. Luckily, it was only 1 mistake, considering I was up until like 11 o'clock doing it. But I didn't find it till this morning. Everybody have one? Cool. Okay. I've posted the document on Canvas right now. So if you're using your electronic note taking, you can download it if you want to. I will be updating and correcting that 1 mistake that I found and reposting it. So currently, if you're on Canvas, it actually says like study guide, parentheses, error in answers. You'll see that parentheses there if you look at the file on the modules. I will be correcting that. When I correct it, I'll take that error message off. So you'll know that it's an updated version. Okay.
Excuse me.
Yeah.
Just a little bit on?
Sure. Like up to there? Yeah, no problem. Okay. Is it okay if I talk while you guys write? Is that okay? Okay. So for Monday, first off, I'm going to give my typical spiel that I always give before the test. Try to get sleep. I know it's going to be hard. It's going to be tempting for you to stay up all night and study, study, study. Your brain will not function on all of its cylinders if you don't get sleep. How do I know this? I had 3 hours of sleep on Wednesday night, and my stats class yesterday felt like a disaster merely because I was running on fumes. I know what it's like not to get sleep. It sucks. You don't want to do that to your body right before a test. Okay. The other thing, if you normally drink 3 energy drinks or 5 cups of coffee in the morning, drink them. If you normally don't. Okay. Don't overload your body with sugar, with caffeine before you go into a test if your body is not used to it. All right. Chemical reactions will happen in your body and it will freak you out. And it only amps up all of those terrible hormones that make you feel bad when you're taking a test, okay? It will enhance your fight, flight, freeze mode. You do not want that during a test. Got it? If you eat breakfast, eat breakfast. If you don't eat breakfast, okay, don't, but you're doing yourself a disservice. If you need breakfast, we can find you breakfast, all right? There are tons of places around campus where you can get snacks if you need them. If you want to bring something in here to eat while you're taking the test, because I know it bridges lunch, that's fine. I don't care. Okay, bring your water. Bring what you feel comfortable bringing. It's okay to do that. All right. What else do I normally say before a test? Yeah, try to keep things status quo, right? Don't do something to put your body into a position where it hasn't been before regularly. You don't want to do that. Okay. The other thing to tell you, if we're looking at that study guide, first off, it is not a practice test. Okay. I don't call it a practice test on purpose. There are too many questions on this test, on this study guide to be a test. You have 85 minutes. No way in the world I would expect you to do 22 problems in 85 minutes. There's not enough time. I know that. But I would rather give you too many questions to practice and have you feel like you've practiced enough than to not give you enough, okay? So if you wanted to act like this is a practice test, do all the odds or do all the evens, okay? I am looking at 10 problems on the test. That's what I'm sitting at right now, all right? So if we've got 85 minutes in class, and there are 10 questions, that gives you 8.5 minutes per question, right? That's a good amount of time for you to sit and think if you need to. Everything from math 1 and prior is fair game. So how to take a derivative, how to take an integral, all your trig stuff, although you will have a calculator, right? So you got to know chain rule, product rule, quotient rule. You have to know how to do those. They're going to be embedded in these Calc 2 problems the rest of the semester. Integral rules, especially use them. we've done a lot of U substitutions this semester, right? Already. We're gonna do more. Know the 6 trig functions on the standard angles of the circle. So standard angles are multiples of 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, it's quadrant 1. If you want to know how to quickly form that, Camila, it was fast, wasn't it? I can show you how to form that table very quickly so that you can memory dump on the back if the trig functions are not your friend. Okay, we can do that. Probably not right now. I'd have to do it outside of class. It just depends on what we do today. Okay. I'm not going to test you on specific things from Math 1. You just have to know the skills. Okay. So not everything specifically about Math 1, but you do need to know all the rules. Okay. On the topics. So notice in 1.5, there's nothing specific tested in 1.5. 1.5 is going to be like an extra homework if you want to do it, to drop another homework later, right? I'm going to drop some of your homework assignments so that you don't have to do all of them because life gets in the way and you're not going to have time to do all of them, right? 1.5 can be one that gets dropped if you don't want to do it. It's a review. I am expecting you to know derivatives of exponents and logs and how to use them with other functions. So product rule, chain rule, U sub, okay? And there are examples on the next page. Logarithmic differentiation, there's one example on there. Essentially, logarithmic differentiation, we used it when there's a variable in the base and a variable in the exponent. That's where the problem happens. Okay, when we've got variables in both locations, we got to use logarithmic differentiation. Integrals of exponents and logs. And notice the derivatives and integrals for exponents and logs, it's any base. Right? It's not just natural log, natural or e to the x, but it's also all the rest of them that we can come up with. But they're very similar. And then the integrals of trig functions and how to derive them. I think there's maybe 1 or 2 problems in here that give you an example of that. Set up and solve an exponential growth and decay problem with given information. Notice, even though 8.3 is listed, I will not give you a separable differential equation. Okay? There is not a separable differential equation on this test. Okay? So if you don't want to do 8.3 yet, don't do 8.3. I think there's only 4 or 5 questions on that homework. There's not that many. So no separable D's. I will give you the formula for the law of cooling, like right here. I will give you that on the test. You don't have to memorize it. You just have to know how to use it and what the symbols mean. Okay. So if we're looking at those symbols, just really quickly running through, do you remember? Oh, and see, I already have a mistake. Put some parentheses around that second one. Apologize for that. So H0 minus HS needs to be in parentheses. Do you remember what the symbols stand for? Can we run through them? What's the HS? Surrounding temperature. So HS is the surrounding temperature. You will be given that, right? You'll, bless you. You have to be given some of these and you may have to find one of them, okay? What about H sub 0? Initial temperature. So what is the thing that you are cooling starting out to be? Okay, and then K. K is your exponential decay constant. It's how it's changing, okay? So you'll either be given enough information to find K, which I think is the problem. Do I have to find K first? Yes, so in number 22 on that study guide, you have to use the information to find K. And then you try to find a value later, like how long, right? You find the time for a different problem. Okay. Derivative of inverse trig functions. So we did arcsine, arctan, and arcsecant in class. Those are the 3 that I would pick from for deriving, if I asked you to derive one, okay? the inverse co-functions, remember those were the pi over 2 minus the other one. So know how to do a derivation for arcsine, arctan, and arcsecant. Okay, you have them in your notes. Okay. And then the integrals resulting in inverse trig functions. Are we cool on the topics for the most part? Do you think I missed anything? Yeah.
What did it say like above it? No.
No separable DEs?
Oh.
That one. So I'm not going to test you on a separable differential equation. We only did like 1 or 2 examples in class, and the homework's really short. So I'm not going to do that. And so notice my paragraph, the problem below are sample problems are what could be on an exam. So if I made an exam, I would pick problems like these. Okay. That does not mean that those problems you have in your hand, all I'm going to do is change the numbers to make my exam. I'm not that easy. Okay. So they just give you a good smattering of practice. And that's the idea. Okay. I want to know what you know. That's all a test is. I want to know how far you've gotten. And then what happens when you get the test back? People that have had my class before,
Correction. You
get to do corrections. Okay. So this is not the end all be all of I'm going to make this grade and I'm going to fail this test and it's going to be it. And my career's over. No. Okay. No, that doesn't happen in the real world. You are given multiple chances to make corrections. Yes, mistakes happen. That's okay. We learn at different paces. That's my goal with corrections. Okay. The corrections are the only things in my class that have solid due dates before December. Okay. So I don't take the corrections after the dates that are posted in Canvas. Unless there's a dire emergency and you got in a car accident and you can't make it here. Okay. Scan it and upload it by midnight. If I need to open that up, I can. I'd rather have the physical copy, but like, don't get into an accident, or if you're sick and you can't come, I can get it. Talk to me first before you think it's all over, okay? If you never ask, the answer is always no. Okay, so ask me. This is not exhaustive, continue to practice. So I know I don't give you enough room on your paper for these problems. So that's why I said, pick another, get your own paper, try to work through it. If you want enough room, like my page here, I do have it up there. You can print off your own if you want. Okay. If you want to print off your own, you can, but you don't have to. What I'd like to do, I think, with the rest of the time that we have is ask you, do you want to work on your own and just work problems on your own and ask when you have questions? Do you want me to give you like 15 minutes to work on your own and look through the problems and maybe circle the ones that are you have no place to, no concept of where to start, and we talk about them? Can we do something like that? So 15 minutes of you working on problems. You can work in pairs or threes, whatever, or individually, whatever you want to do. And then in about 15 minutes, we'll come back and talk about it together. And I see you guys in the back. I'm coming. So I'm gonna pause. Okay. So before we talk about problems that you are struggling with, number 14, the answer is incorrect. So I had the natural log 2 in the wrong place. Toss it on the denominator instead of being multiplied by it. Okay. So make sure you change that. I will update that on the online version. So you have it, but make sure you make note that 14, the answer is slightly wrong. Okay. The other answers are fine. The only one I didn't get to check specifically myself were the 2 word problems. I got through 21A. But I didn't make up these problems all on my own. I'm not that clever. So I'm fairly confident 22 is correct, like 99.9% sure number 22 is correct. And I will be doing this problem after class anyways to make sure that it is. If there's a mistake, I'll send a message in Canvas, but I really don't think there is. I trusted the source that I got it from. Okay, cool. All right, so looking at the problems, And also, by the way, I will have this filled out. I know I still need to fill out some in your other notes, but I'm probably just gonna scan the notes that I did already instead of having to copy it over again. I'll have the solution up here for you by this afternoon. So you can look through the way that I did it, but keep in mind the way that I did it isn't the only way to do it, okay? Some of you did other ways, you used other properties, you still got an answer that would simplify to mine, that's fine. Okay, there are multiple ways to approach every single one of these, pretty much every single one of these problems. In the first few problems, 1 through 5, was there 1 or 2, or let's do 1 through 6, because they are paired in twos for the most part, all the way through 10. Was there 1 or 2 that stood out of just like, I don't know what to do, or I'm trying to do it and I'm stuck? Yeah, Nate.
So for did you talk about 14 already in terms of like the formatting? Because I don't know what's going to the X.
Oh, no, we didn't talk about that one, but I can look at it. So 14, this is X times 2 to the X squared.
Okay, this one of the.
Yeah.
Correct.
Yeah. So the thing with these exponents, that's 2 to the power, and X is getting the square, not the 2. Okay, so we cannot use exponent rules to say like 2 to the X squared. No, it doesn't work that way. It's 2 to the power X squared. So the X squared's got to stay together. But yeah, that's the multiplier by the X. Yeah. Okay. 1 through 6, anything stand out? You're just like, I don't know what to do. I need a hint. I want to look at it straight from top to bottom. Any of those? Yeah, Kate.
Number 8.
Like, that's not 1 to 6.
Oh, sorry.
It's okay. 6? We can look at number 6. Number 6? You look at that one? Okay. The other thing that I want to tell you, I know that the answer key is pretty simplified as far as algebra goes. If you take a derivative and at least clean it up a little bit, I'm pretty much okay with that. So if your answer is slightly different from mine, but if you make one more step to simplify it or factor something out, that's fine. You don't have to factor the stuff out. Okay. So it's okay to leave it unfactored as long as you're simplifying anything in there that you can cross out because of factoring, you know, because like 2 times 1/2, don't leave them there. Go ahead and cancel those out. +1, -1, go ahead and simplify that, right? So in this one, if we're taking the derivative, what are we gonna do? Quotient rule. Yes. So we're gonna do a quotient rule on this. Almost. It's the other way around. Low D high minus high D low. Yeah. So 1 plus natural log 2x times derivative of natural log x. I'm going to write it out. We'll just write it all out. Oops. Hang on. Minus natural log x times derivative of the bottom, 1 plus natural log 2x, all over 1 plus natural log 2x squared. Make sure the square is on the outside. And I'm going to scoot this over so that problem's no longer going to be there. It's just going to be the derivative part. Okay. Yes, quotient rule. You gotta know the quotient rule. If you don't want to use quotient rule, you can use the product rule, move the denominator up, put it with an exponent of -1 and use chain rule. That's fine too. Okay. So if you don't want to use quotient because you know product, move the denominator up, give it an exponent of -1 and go from there and use chain rule. Okay. That's perfectly valid to do. In the top, what is the derivative of natural log x? Yeah, so 1 plus natural log 2x is going to stay. Derivative of natural log x is 1 over x. Minus natural log x times derivative of 1 plus natural log 2x. Derivative of 1. 0. Yep, so we're here. Derivative of 1 plus derivative of natural log 2x. One over 2x times the derivative of the inside, derivative of 2x is 2. Good. All over that thing squared. 1 plus natural log 2x squared. Now, I know I'm showing a lot of steps. Am I expecting you to show all of those steps? Probably not. It is okay if you don't show the derivative of the other ones like I'm doing in the first step, okay? If you want to skip to the second step, you totally can, if you feel comfortable doing that, okay? Keep in mind, I grade with loads of partial credit. So if I can follow what you're doing and it makes sense, you're good. You get points for trying, so don't leave any of the answers blank. So,
Sorry, just for that last term on the numerator, 2x.
Mhm.
Is that squared?
no, times 2,
Oh,
because you're multiplying by the derivative of 2x. Right? Derivative of the inside. Yep, it's a chain rule again, right? Derivative of natural log of 2x, 1 over 2x times the derivative of 2x. Yeah. Which is kind of cool because the 2's cancel. That's nice. And then a little bit of cleanup if we can. Do on this one. I gotta find the right one. Hang on. Where did I get on this one? That one. Yeah, okay. So both of them have this 1 over x. Do you see that? They both have that 1 over x factor. Can I take that and just put the x in the denominator? Yeah. We got algebra skills. Okay. X 1 plus natural log 2x squared. We're going to throw that 1 over x to the denominator. Since both of them have it, we're factoring out the 1 over x, and we're just putting the x in the denominator. So there's my 1 over x right here. Okay. Now what? Can I clean up anything up top? We've got 1 plus natural log 2x minus natural log x. If you get to this point, I'm okay. Like that would give you full credit. But I do want to try to encourage you a little bit. Like use the algebra, use the properties you know, because you'll need to simplify them at some point. Can we simplify it? Something happens with those natural logs. We could separate the 2x. Ooh, you did it a different way than I did it, which is totally fine. Yeah. Okay, so Ramesh is suggesting to separate natural log 2x into natural log 2 plus natural log x. That's perfectly fine. That would work. I did it slightly differently, but both of them are going to get us the same answer. Yeah.
you could do the, is it called the closure rule, where you like divide the arguments?
Yep. So Ramesh is suggesting separate the 2x into natural log 2 plus natural log x. Zoe's suggesting take that subtraction and divide them. Because if you're subtracting logs, that's really dividing exponentials. And if we do that, no matter which one we do, take a look at what happens with the x's, right? Natural log 2 plus natural log x minus natural log x, those are going to cancel out. We're left with natural log 2. How about down here? The x's cancel, we're left with natural log 2. So in both cases, as it should be, right? It doesn't matter which way we do it. We get the same answer. So we end up with the 1 plus natural log 2 over x 1 plus natural log 2x squared. That's our answer. Cool. But as mentioned earlier, if you get to this step and you don't simplify the natural logs, for this first test, I'll be okay with it. It's okay to leave it there. But see what I mean by cleaning it up a little bit? Clean up those derivatives a little bit. Cool. So that was number 6. Do we have another one in 1 through 6 you want to look at, Maya? Looking at number 5? Yeah, 5 was a monster. Okay. There's a couple of different ways to do this one. So I did it like Zoe did it, because I saw you doing it this way too. We just basically just chug at it right away. 1 over the argument times the derivative of the argument. Okay, now the derivative of the argument's gross. It's big. It's a product rule with a chain rule. It's going to take a while. But Ahil had a different idea. Did you get yours done?
No, I did.
So just an idea, instead of right away doing it, you could separate this and then do it one more time and pull that 1/2 out front. That's enough. So I got to separate them, right? These are y. This is just using those log properties to simplify y. And we can take the derivative of that. It's a tiny bit faster than having to deal with that product rule up in the top. Are you going to get the same answer? Yes. As long as there's not a mistake, right? You'll end up with an answer that's equivalent to the other answer. I don't care which way you do it. Okay. But can I leave you with that hint? Is that okay? Or you want to see it all the way out? What do you think? You want to see the first step on leaving it the way that it is and going? Or do you want to see the simplified form? What do you think? What was your question, Maya? What do you think? What do you think? What do you want?
I want to see the full thing because I got the same answer.
Yeah.
But instead of the parentheses at the bottom, I said my square root. So I'm really
Oh.
confused.
It's in the simplification. I know what you're doing. Yeah, yeah.
I don't know what happened.
That's okay. Okay, so if we just do it straight from that one, okay? 1 over the argument times the derivative of the argument. That's a derivative of natural log. Okay? So I'm going to go from this one, right? We're not separating the log into different components. It is a little bit easier, but we're not doing it. So let's take the derivative on the top. Product rule, right? First times derivative of the second. Is it okay if I go ahead and take the derivative instead of writing it out? So derivative of the second, I've got 1/2 x squared minus 1 to the negative 1/2 times what? Derivative of the inside, which is what? 2x plus derivative of the first is 1 times the second, x squared minus 1 to the 1/2. Okay. Okay. I can't take that negative 1/2 exponent. I can't do something with that yet because I have a plus sign. Right? So I can't just move it to the bottom because I've got the plus sign over on the other side and it doesn't have a negative square root or negative 1/2 power anywhere. So I got to do something different. When I saw this, my instant idea was to multiply by a special form of 1, multiply by x squared minus 1 to the 1/2, top and bottom. Because if I do that, yeah. Oh, you found it? Okay, okay. So if you do that, if you're multiplying by a special form of 1, notice the x squared minus 1 to the 1/2 times x squared minus 1 to the negative 1/2. We add the exponents. What's negative 1/2 plus 1/2? 0. That's going to go away. And that's what we want to happen anyways. So we've got x times, we're on number 5. x times 1/2 times nothing, 2x plus x squared minus 1. What's 1/2 plus 1/2? That's a 1. So we can just leave the x squared minus 1 all over the denominator, x times x squared minus 1. And I've got another 1/2 power times a 1/2 power. We add them together. 1/2 plus 1/2 is another 1, right? So essentially all the square roots go away. And simplifying this one, cross out the 2's. Notice we've got x squared plus x squared minus 1, x times x squared minus 1. That's where the 2x squared comes from. Okay. As far as cleaning it up, I would expect no negative exponents. So I want those negative exponents to go away, right? We're a little bit more advanced now. We're in Calc 2. We can make that algebra work. Make that negative exponent go away. I'd probably be okay at that step. I really want that one. If this were a test problem, I'd really want that one. But if you get to like this step, this first line step, right? The x times 1/2 times 2x, not going to take off a whole lot because you're almost done with it. Okay. Questions? Comments? Yeah, Amir. Yep. If I can make it work. How far zoomed out you want me to do? There? Okay. So we worked through 5 and we worked through 6. So now look at 7 through 10. I heard 8. Cade said 8. We can take a look at that one. Number 2? Yeah. You can do number 2. Let me know when you're done with 5. Good? Okay. Flipping back up to number 2. Hang on. Y equals e to the power tangent x. Nope. Okay. What's the derivative of e to a power? E to the power times the derivative of the power. Okay. Doing that chain rule, right? Derivative of e to the x is e to the x. Derivative of e to a function is e to the function times the derivative of the function. We're just going back to that chain rule. And then what's the derivative of tangents? Math 1 special. Secant squared. Okay. And I don't care what order it comes in. Secant squared first, e tangent x. Okay, fine. Multiplication's commutative. I don't care what order they come in. Same with addition, right? It's equivalent. Cool. Did number 3 trip any of you up? Because I tried. No? That one was too easy? Yeah. Yeah, I can do number 3. Thanks for being brave. How do I take the derivative of x to the 5th? What is it? 5x to the 4th. Good job. Plus derivative of 5 to the power x. 5 to the power x. Here's where, because it's not e, it's a different base, I've got to multiply by that factor, natural log of the base. Okay, so this is coming from derivative of a to the x is a to the x natural log a. That's where that's coming from. Okay, you do need to know that. You need to know where the natural log of the base pops in on exponents and on logs. Okay, that's why I tried to put some in there, smattered them around. Cool. All right. I know 4 gave some of you troubles, but I think you got it straightened out. Okay, let's take a look at number 8. That was another one suggested. You got to look at the big picture, what's going on. Is it only a log question? Are we multiplying functions together? Do we have a chain rule? What do we have to do first? How do we kick it off? Let me start. Yeah, sorry. Product rule? What's your first function? Yeah, let's let 2x be our first function. What's our second function? The log one?
Yeah.
Yeah, let's use product rule. Okay. I better not see any equal signs after that y, by the way. It should not be, let me be clear. It should not be that and then the derivative, right? Why? Derivative is not the same as the function. There's only one function in the world where the derivative and itself are the same. E to the power x. That's the only one where your derivative and your function is the same. So write out y prime, write out dy over dx, whatever you want to indicate that you're taking the derivative. I know some of you aren't doing that because I saw as I was walking around. Make sure you're labeling it as your derivative, okay? Want to know that it's your derivative. Okay, so first times, I like to do first times derivative of the second. If you like to switch it around the other way, that's totally fine. It doesn't matter, right? First times derivative of the second, log base 10. I'm going to make this x to the 1/2. Oh, and we could clean that up even a little bit. Ew. We could simplify it before we did this, but that's okay. I didn't, so I'm just going to go like it is. Second, log base 10 x to the 1/2 times derivative of 2x. So if you do it with the derivative of the first times the second first, right, your terms are going to be switched from mine. That's okay. It's the same thing. So 2x times derivative of a log. And this one's complicated. It's got extra components to it. So it's a derivative of a log. I'll give you a hint.
X times the natural log of the base.
Yep. So this time we have x to the 1/2. So we're going to keep that x to the 1/2 in there. Natural log of 10. Sorry. Natural log of the base. And then we've got to multiply by what? Derivative of x to the 1/2, right? You've got to do the chain rule. Unless you pull that 1/2 out in front. And it's a whole lot easier. That algebra is a whole lot easier if you do it. And I'll show you what I mean in a second. But let's say we don't see the algebra because we're already anxious about the test and our brain isn't working at its highest function, which will happen. And that's okay, right? You're just going to go at it and that's okay. Plus derivative of 2x. 2 natural, I'm sorry, log base 10 of x to the 1/2 there. I will write it log base 10, even though log base 10 of x is equal to log of x like that. I will put the base 10 on there only because I'm feeling generous. And it's easy to forget that an log without a base is base 10. It's easy to forget that. So I'll make sure that the base 10s are on there if there's a base 10 log. Let's take the derivative of that x to the 1/2. See if we can clean that up a little bit. Derivative of x to the 1/2. Yep, 1/2 x to the negative 1/2. 2 log base 10 x to the 1/2. Okay. I don't like the negative 1/2 there. right? That guy's got to go somewhere else. I can just put it with the other one, right? Oh, twos cancel. Let's cancel the twos. Make them go away. So the x to the negative 1/2 is going to go with x to the 1/2 and become x, right? Natural log 10. But then the x's cancel. Are we okay so far? I know there's a lot of algebra in this one. If you cancel the x's here and you make those ones, the 1 over natural log 10 plus 2 log 10 x to the 1/2, this one's okay. I would do full credit on that. As long as you got 1 over natural log 10, right? Cancel the x's. There's one thing you can do to eventually get it into the form that I have on the answer key. What is it? Why is there no 2 on the log 10? I'm just looking at the answer key. Yeah?
Because you can bring it back to the, like, you can square the argument.
That exponent can come out front because it's a log. And that's how you get that answer. 1 over natural log 10 plus natural log base 10. I'm sorry, plus log base 10 of x. Yeah. But I'm okay with the one before. I'm gonna be a little bit lenient on the log rules merely because I know it's been a while. You probably last saw log rules before this semester in what, college algebra or pre-calc, which was at least a year ago, likely. Okay, so I'll be a little bit lenient on it. What I was thinking earlier about simplifying it similarly to the previous problem, you have 2x log base 10 square root x. If that's x to the 1/2, just like we did down here, we can take the 1/2 and throw it out front. And we end up with x log base 10x. That's a whole lot easier to work with. You'll actually end up with almost immediately the very last line. Elijah.
How does the fraction, come
Which fraction?
in the second, 1 over x?
This one?
Yeah.
So let me get a different color. So looking at this one, so that is coming from that derivative of log base 10 x to the 1/2. Derivative of a log is 1 over the argument. But because we don't have a natural log, we have log base 10. We have to multiply by natural log 10 on the bottom. And then the rest of it is that chain rule derivative of the inside. Yeah. Cool. Questions on that one?
So how do you, what happened to, why didn't you keep the chain rule on denominator x to the power of 2 and then the natural log 10? Or
You're talking about this part right here?
yeah.
Well, that is the derivative, right? The derivative of log is 1 over the argument. So I've got to keep the x to the 1/2 there. Multiply by natural log 10. And then I take the derivative of the argument. So let me write it out a little differently. Derivative of log base b of a function. Okay, so this is a rule, is 1 over the function times natural log of the base. On top is the derivative of the inside. So when I do the 1 over x to the 1/2 natural log 10, that's part of the derivative of that log base 10. So I am taking the derivative. It just stays there. Because that's this bottom part right here.
And then after that, your answer, how come it's not did you correct it was the question 8, one of the, never mind.
Cool. Okay. Any other ones? Number 9 or number 10? You wanna pick one? You wanna do some integrals? We only have about 10 minutes left. Class goes so fast. Can we do some integrals? Let's do some integrals. Okay, 11 through 14, what do you think? Because they're kind of related. Okay, I'm just gonna run through this really quickly. 1 and 2, derivatives of exponentials. 3 and 4, derivative of exponentials with a different base, right? Base 5, base 4. 5 and 6, derivatives of natural log. 7 and 8, derivatives of logs of other bases. 9 and 10, inverse trig. I did pair them together. That's why I said do all the even ones or do all the odd ones. Make your own test, right? It gives you 11 questions instead of 10. And I told you there were going to be 10 on the test. It's close. Okay. Okay. As far as 11 through what, 18? So 11 and 12, integrating exponentials. 13, 14, integrating exponentials with a different base. 15 is integrating with a natural log. Yeah, 15 and 16 integrating with a natural log, believe it or not. And then 17 and 18 are inverse trig. So I didn't put any integrating with logs with a different base in there. Okay, I won't test you on it. Just know how to use them. And then you've got a log differentiation, implicit differentiation to derive arctan, and then a half-life and a cooling temperature one. I doubt I'll be able to put both of them on there. I will see how long it takes me to do it. Okay, so if we're looking at 11 through 14, is there one that stands out that you want to look at?
Fifteen.
15? 11 through 14. You guys are so funny. That's okay. Kay did the same thing. Zoe. Number 11? Okay. Can we start it? And then I'll let you finish it?
Yeah.
Okay. Bless you. So if we're looking at this, oh no, we've got a product. We don't know how to do products yet. But what do you notice in the power? Power has a power. Okay. Let u be that. If u is x to the third, what's your derivative? 3x squared. If we move stuff around, dx is going to equal du over 3x squared. Oh, that's what we want because we've got an x squared there. We want that to be x squared. Oh, I can't use that color. Sorry. We'll do that, right? So the x squared on the bottom in my derivative is going to cancel with the x squared that I have up there. So we can substitute x squared e to the u times our dx, du over 3x squared. And if we do that, x squared and x squared are going to cancel. Actually, this one's going to be fast. 1/3 pops out, integral e to the u du. Ooh, you know what that is. What's the antiderivative of e to the u? E to the u. Fabulous. Substitute it back in. Cool. E's are my favorite. I love E. Your whole test is not going to be E's. If only, right? I just love them. It's one of my favorite numbers.
It went from 1/3 to 1/2.
Oh yeah, I'm making stuff up. Just kidding. If you ever want a fun little experiment, come to a math club where I teach you that all the numbers are equal to each other. They're really not.
So there are no wrong answers.
Yeah. Now, it was one of the first proofs that I saw in my proof technique class. So when you become a math major, you have to learn how to prove things. It's kind of like deriving, integrals and derivatives and such. But there's a whole class on proof techniques. Are any of you in discrete math? Math 10, CS 17? Nope. Maybe going to take it? It's a cool class. They teach you a little bit of proof techniques in that class. but I had a whole class on it, and my professor, one of the first days he was in there, he proved that all the numbers were equal, and it blew all our minds for a second. And then, oh no, there was an error, and it was an intentional error. We had to spot the error. That was the goal of the task. But anyways, it's a fun one. So are you okay with 12, even though it's not written as an integral? How do you find the area under a curve? Integrate it? Cool. It's a definite integral. It's pretty straightforward. Okay. So 13 and 14 seem okay. Okay, so Connor said 15? Cool. All right. So for 15, I know that it's tempting to try to do a U sub. Don't. Your first step, separate it. X squared over X plus X over X plus 1 over X. Right? Go ahead and separate it into individual fractions, because those individual fractions will actually simplify into really nice things. And they're easier to integrate. So if we do that, X squared over X becomes what? X over X becomes what? 1 over X stays the same. Okay. Integral of the first two terms, you know how to do that from Calc 1. Right? So X becomes antiderivative. X squared over 2. 1 becomes antiderivative of 1. X. 1 over X. Here's the Calc 2 part. What's your antiderivative of 1 over X? ln X. Evaluate that from 1 to E. Plug in E, plug in 1, subtract them. Okay. Can I leave that there? Okay. Be careful with your signs, right? Subtracting the 1s. That's a terrible ln. There we go. A little bit prettier. Okay. 15, 16, 17, 18. Anyone in there that you're just like, I need to do this problem? Or I need a hint? We can do hints. I'll give you a hint. You do not know how to integrate logs, right? U is the log. If you don't know how to integrate it, right? We don't know how to integrate logs. Like with the word log in it, we don't have an antiderivative for log yet. And we don't have antiderivatives for inverse trig functions. We have derivatives, we don't have antiderivatives. Those are your U's. Okay? So let U be log base 3 of X. Yeah, Alejandro.
Can you scroll back up to the number of 15, sorry?
Can you do it in a second?
Oh, yeah.
Can I do it in a second? And then on that one's an inverse. I don't want to do that one. This one right here on 18. So 1 minus X squared squared. That's the hint I'll give you on that one. Okay. As for the rest of them, I'm going to scan my notes and post them to Canvas. As soon as I finish 21 and 22, I will scan them this afternoon and post them. So you will have all of my solutions. My way to do it's not the only way, right? We have other ways to do it. Totally fine. Questions that happen over the weekend, send me messages. I will answer them. I have 2 soccer games to go to tomorrow, so I'm going to probably be bored. I love my kids, but kids soccer can be a little boring sometimes. And you said 15, Alejandro? 15. All right, I'll scroll back to 15. Whatever happens on Monday, you'll be fine. It's one single test, you get corrections. Have a good weekend. Study your hours. You'll be okay.
Can you do all a lot of them without the notes? Can you do any of them without the notes? Any of them? You have to refer to your notes for all of them. Okay. That gives me confidence.
Okay, now you just used to. Yeah.
Okay, that gives me confidence. So I got a good grade, and if you also, you don't see, I make you feel like
Yeah, I think you're doing great. Oh, well, thank you. Like,
I think one of the last problems, hang on. Was there one on here? Oh, I forgot there was another mistake. I thought I had you do something, but turns out I didn't.
oh, yeah.
So to answer the question, will the arc or the inverse trig function derivatives be given? No. But you only have to know 3 of them, not all 6.
okay.
And so the 3 that you'll need to know are the sine, tangent, and secant, which were the 3 that I underlined at the beginning. Yeah. Hi, guys. Yeah, you're welcome.